All right, so let me go to my handy dandy board and we'll start. Well, I've already pulled it up. Darn, I'm not hitting on all 4 cylinders this morning. There we go, and let me go ahead and do this, because if I don't, it won't be right. Now, just to review, your exponential laws. Well, why are you going to do the exponential laws? Because the logarithmic laws are, just come on in there. The logarithmic laws are derived from the exponential laws, because a logarithm is a glorified exponent. So, here's the first one. These are exponential laws, and I want you to write them down, because I want to, well, if you know them by heart, you don't have to, but some of you may not remember them. Rules, laws, whatever you want to call them. I don't care what you call them. Properties, whatever. The first one is called the product rule. And the product rule says that if I have 2 terms with the same basis, and I am multiplying them, x to the m times x to the n, what do I do to the exponents? Add them. You add them. X to the m plus n. And that's pretty self-explanatory. And y'all remember that from pre-algebra or algebra 1. The second one, anybody know what the second one's called? Quotient rule. Good. You must have had a good math 102 teacher. Is I. Quotient rule. If I have the same bases and I'm dividing, what do I do to the exponents? Yeah. Somebody crawling up the wall over there? 3. Anybody know what the third one's called?
The just quit rule.
What? I quit rule? Yeah. I have the power rule. And that is when you have an exponent raised to an exponent, what do you do to the exponent? Multiply them. Now, these rules right here above this line, they are basically to help you with the mathematics. The next 2 rules is to make it look better. And that's the inverse rule. Which says if I have x to the negative n over 1, what do I do to make that look better? Flip it. And it becomes 1 over what? X to the positive n, and vice versa. If I have 1 over x to the negative n, I can flip it and get x to the n and over 1, which is x to the n, and I can get rid of the what? The negative exponent. So that, to make it look better. Now it is better to work with positives, so you could argue that it helps you mathematically. Most of the time when you use the inverse rule, you're using it in your answer to get the negative exponent positive. And the inverse power rule that's when you have a different animal with an exponent. You have something in parentheses raised to a negative exponent. And that's x to the n over y to the m. And you flip what's inside and it changes the negative w to a what? Positive. So that would be y to the m over x to the n raised to the w power. Now, like I said, these are pretty much to make your answer look better. This one is used more mathematically than this one is. Although, in some, if you pick a certain method of getting exponents simplified, you may use the inverse rule or a variation of the quotient rule, because the quotient rule and the inverse rule are pretty much the same thing. These two are pretty much the same. But we're not going to do any of these problems. I'm just showing you the rules so you can get your mindset started with whenever I see multiplication, what am I going to do? I'm going to add. Whenever I see division, what am I going to do? And whenever I see power, that means I'm going to do something with the exponent. All right? So these three right here are the main reasons I want you to write these down, because this is going to go into the logarithms. Now, the number one thing you need to realize about logarithms, and you got to memorize it. You cannot get by with not memorizing it. And I'm going to show you what page it's on so you'll have it. No sneezing, please. Darn, I hit the wrong thing. Oh well. What page, what section does logarithm start on, so I can go right to it?
I think it's 5.
5 what? 5.3. 80% of your test that you have the last day of class, the Unit 3 test, will be on logarithms. The other 20% will be on graphing exponentials, which is not hard on the graphing calculator, or vertical and horizontal shifts with exponentials. You need to know logarithms before you take trig or calculus. You need to know the properties. All right, let's look see what we got here. Yep. And there is the number one thing. It's on page 359. Right there. If you don't have it, if you don't have your book, there it is. Hold on. It's called the definition of a logarithm. In other words, y is equal to log base b of x. That can be rewritten, and you can rewrite it both ways. In other words, you can go from here to here, or you can go from here to here. You can rewrite a logarithm as a what? As an exponent. Now, I'm not going to sit here and try to explain to you why we use logarithms. Huh? A to the y is equal to x. I'm sorry. Okay, b to the y. And this is usually written as b, but they wrote it as a, so this needs to be a. Sorry. Usually that's b, but they made it a for some reason. Sorry. Let me fix that. Now you're going to have to remember, I don't know why this pen's acting up. You're going to have to memorize this property along with your properties of logarithms. And there's about 4 of them that's important. This is the first one. You've got about 3 or 4 more that you have to memorize. Now, why do you have to memorize it? Because you don't. Do you remember when you learned how to do the shortcuts? And you learned how to do complete the square? You can't focus on doing the technique when you're trying to memorize the technique. You know what I'm saying? It's kind of like if you were taking a karate class and you were doing a form. All right? What's easier to learn? Is it easier to learn the form, learn the moves, and then work on the technique? Or is it easier to do one step of the form, learn that step, then do the next step and learn that step, which is easier for you? Most of the time, it's easier to know what the whole form looks like first, and then get it in your head, and then work on the technique. You don't have time on a test, or you don't have time while you're trying to do homework to try to memorize the properties while you're trying to do the problems. It don't work that way. You got to memorize the problem before you start working on speed and technique and speed. So please don't try to write them down or look at them in a book or look in your notes while you're trying to do your homework. It doesn't work that way. Now, that basically means that if I'm given an exponential equation, I can rewrite it as a logarithm. Or if I've given a logarithmic equation, I can rewrite it as a exponent. Now we're going to do an example here on the next page. Now this comes in handy. When does this come in handy? Right now? No. This comes in handy when you're solving equations with logarithms. This comes in handy when you're solving equations, whichever section that is, probably the next couple of sections. All right, so that's where this comes in handy. All right, so that's number one. And let's do an example. On the simplicity scale, it's probably a 1, with 10 being solving an equation. All right, let's look at this one. X is equal to log base A of 4. X is equal is that what it said? 8. I'm sorry, 8. This pen is not, no, I'm not hitting the right thing. Log base 8 of 4. Now what I tell students to do, the way the property is written is this way. Y is equal to log base A of X yields A to the Y. Have y'all noticed that this pen is just not working right this morning? A to the Y is equal to X, right? Make sure I didn't memorize it wrong, because sometimes I have brain bubbles. And what I tell students to do, this is what I tell students to do. If you suck at logarithms and you think they're difficult, then you need to do this method, at least with these. And what am I going to do with this guy? I'm going to move it directly under this guy right here. All right, you with me? In fact, I'm going to make it a little bit bigger, so that way it'll match up better if I can. Dummy. There. You with me? Now, there's only one problem. I wish they would not do this. No way. All right. What's my x equal? X is equal to 4. So I'm going to put x is equal to 4. What's my a equal? A is equal to 8. And what's my y equal? X. Now, don't think too much. They shouldn't use the same variables, but there ain't nothing I can do about it. You can change this to a W if you want to. Change it to a Q. Change it to a T. Change it to a C if you want to. Alright, now I'm going to take this, and what am I going to do over there? I'm going to take these and do what? Plug and chug. What is my A? 8. What is Y? 8, I'm sorry. Y is equal to x. 8 to the x is equal to what? 4. Now we can solve this equation, and it's good that this equation came up because you need to remember how to solve an exponential. I'm going to give you a scenario. I'm trying to think of something that you know how to do. Okay, let me give you an example. Every year, we as faculty members have to fill out a form, and we have to put what we're going to do whatever the year is, the future. We got to put what we call objectives and all this crap, and we have to tell our boss what we're going to do. One of my objectives from last year was videotape and capture my courses, my lectures, so that the students can use it when they miss a day, or they can use it when they suck at a certain material or whatever. I didn't put that in there. I didn't put suck, but but I had to make it all pretty. And we have to do those once a year. Now, it's taken me 20 years to finally get the process down. Why? Why is it taking me up to 20 years to finally get it to where I don't have to ask any questions?
We do it yearly.
So
you don't do it as frequently.
Exactly. All right? Same thing with this type of equation. This equation right here is simple. But why do people not know how to solve it? Because you don't see it very much. Okay? When you see a problem like this, the first thing you think of, same base. Write that down. When you see a problem like this, you think of same base. That's the first thing you should think of. Why? Because you have a variable in the exponent. Can anybody tell me how to get an exponent down? Hard to do. Oh yeah, just take the x root. Well, that don't help you. That don't help you at all. Because the x root, you don't know what x is. So you think of the same base. What's the first number that comes to your mind when you think of 8 and 4? 2. So you write this in form of 2, and you write this in form of 2. So what's 4? 2 to the second what? Power. And what's 8? And that's raised to the x. Oh my gosh, we got to use the power rule. So that's 2x to the what? I'm sorry. This pen is making me miss problems. 2 to the what? 3x is equal to 2 to the second. Now, somebody tell me from your Algebra 1 days, what is the rule I'm fixing to present to you here? Huh? I've been introduced to giving up a little. When you see a problem like this with an exponent that has a variable in it, what should you do? Quit. What, does anybody know the rule? You're wrong. When you have the same base and there's an exponent, or when you have the same base, what are the exponents? If the same bases are equal, what are the exponents? They're equal also. That's the rule. No, it's not a written rule. I mean, it could be a written rule. You can look it up. Variable, how to solve a variable in the exponent. I don't know what you actually call the rule, but if you have the base, if the bases are the same and they're equal, then the exponents are equal to each other. So what's the next step?
Solve the rest.
3x is equal to what? And x is equal to, and you just figure it out. So 8 to the 2/3 power. Somebody take your calculator and take 8 and raise it to the 0.67 power, or 0.666666667 power. What do you get? 4. What did you raise it to? 0.67? Do 0.666666666. And what do you get? It's numerical. And that's how you do it. Now that's solving this right here. From here down is solving, all this right here, is solving a variable in the exponent. It's not logarithmic. It's just, now you're going to use it when solving equations with logarithms. You're going to use this. You're going to use this, and you're going to use this. So in your homework, you need to do these like twice. The problem like this one, these, you need to do this one and then hit similar exercise 2 or 3 times to make sure you get the hang of this. I don't know if they showed you to solve for that. Did they show you to solve in the example? Or which one did we do?
The one to the top of the page.
Is it the top?
Well, we're looking. Right. Keep going up.
I can't see nothing.
Right there.
Okay, B. Did we do B?
No. You do that.
Oh, okay. Oh, okay. Yeah, they did it right there. Set okay. Okay, they said the power rule. No, the power rule is right here. There it is. Here it is right here. If A to the B is equal to A to the C, in other words, if the bases are the same, what are the exponents? They're equal to each other. And that's what you need to remember. So you need to highlight that one right there. The power rule is used to get the 3 and the x together. Yeah, they should have put this right here and draw an arrow here to here, because that's misleading right there. All right, let's do the other one. Let's do the other one, and then let's do one that looks complicated, which is going to be what? C. Do C. Log base 4x is equal to 3/2. Log base 4x. Log base 4x is equal to 3/2. And I'm going to go back and get my handy dandy. Oops.
Notebook.
Yep, my handy dandy notebook. And it actually worked. There we go. I'll have to move this over a little bit. Really? I'm sorry, but I work with CAD every day drawing flats, and this program they should make this like CAD, but they don't. And I'm going to take my handy dandy property. Okay, now this one is it the same order as this one? Yes or no?
No.
No, it's not. So we need to turn it around. So we're going to turn it around. I'm going to draw it down here and I'm going to turn it around. 3/2 is equal to log base 4 of x. Okay, this board sometimes can be frustrating. Most of the time it's frustrating. But at least I don't have to erase it when I get through the classes. Just delete it. I should start saving it and sending it as an attachment or posting it. There's something else. I need to put that down for an objective for this year. Anyway. Alright, so let's write down everything. Read from left to right if you want to, or start alphabetically. A. A is equal to what? 4. X comes next. X is equal to X. And Y is equal to what? Plug and chug. So 4 to the, thank you, 3/2 is equal to X. Now, wait a minute. Don't reach for the calculator, because you can. This is an exponential fractional exponent, which can be written as a what? Let's go back to the original exponentials. I always throw this one in as a extra rule, and that is number 6. The square root of x to the first power is equal to x to the 1/2. Now, I don't write it in terms of x and n because that's an easy rule for you to remember. The square root of x to the first power is equal to x to the 1/2. So tell me what I did when I rewrote this as this. What did I do? I put what over what? What did I put over what? I put the exponent over the what? The index. Exponent over index. Somebody got mad and left. You need to remember that for calculus, because you're going to see that quite a bit. Exponent over index. If you want to rewrite a radical, you put the exponent over the index. So with that in mind, what's this right here?
Cube root of x squared.
Exponent over index. So what is it?
Square root of x
Square root of 4 to the what? Now, how many different ways can you do this? 2. You can say 4 times 4 times 4 is what? 64, and take the square root of 64. Or you can take the square root of 4 and raise it to the third power. Either way, you're going to get what? 8. It's kind of hard to mess this up, but y'all will find a way. Okay? So I'm going to do 2 ways. I'm going to say the square root of 64 is 8. Or I'm going to say 2 to the third power is equal to 8. You can do it 2 different ways. The square root of 2, the square root of 4 is 2. 2 to the third is 8. Or 4 to the third is 64. The square root of 64 is 8. Now do you see how logarithms is a exponent dressed up? Like putting lipstick on a pig. It might look nicer, but it's still a what? Still a pig. That's what a logarithm is. It's basically a fancy exponent. Now, the second rule that's important that you need to memorize, that's the definition of a logarithm. This right here. Oops. That's the definition of logarithm. The second is the product rule. Log base A of x plus log base A of y is equal to log base A of what? Why did you get x, y? How did you, just leave and come in whenever you want to.
Well, thank you.
Why did you say x, y? Why did you say x times y?
Product rule, that's why.
Because the product rule in exponents dictate that if you have an exponent, if you have something in exponent by same base, what do you do, and you're multiplying, what do you do to the exponents? You add them. So this one is saying, if you're multiplying with the same base, x and y, what do? You add them. Same thing.
So how does that look on the other side of the equation? You know, where you do a to the y equals x? Because I look at that log a, base a, y, it's confusing me.
Okay, first of all, what do you mean? Log base A.
You know how like one is, it can be rewritten in a way that
Mhm.
it looks more tangible? Like,
We're gonna get to that with the change base formula. Just wait. Just be patient. Can I be in charge for a while? What's the next one gonna be called? Quotient rule. And I'm not gonna put for logs, I'm just gonna put quotient rule. Now what do you think the quotient rule is gonna say? Crap. What'd you say? Subtract. But tell me. Just put it in form of this and tell me what it would say. Anybody? Log base A of x. Log base A of y. That's. Now he put that together, and y'all put it together in your mind just by using this and your application of quotient rule for exponents, because quotient rule for exponents puts subtraction with what? Division. And your exponential laws, the product rule, puts addition with what? Multiplication. So if you know your exponential laws, how hard is it to learn the logarithmic laws? Not very. Just put a log in front of them. And then what do you think the third, Robert? That's number 2, 3. What do you think number 4 is called? Tower rule. Boy, y'all are just exceptional. And what do you think the power rule says? Well, I'm not going to ask you to do the power rule because the power rule from logarithms is a little bit different, but it's based on the exponent that's up, up there high, and you do something with it. Log base A of x to the n power can be rewritten. Anybody want to take a guess at it? Anybody remember from a previous class what you do with that n? Pull it out front as a coefficient. Okay, and you can go all of these rules. You can go both ways. In other words, if you're given this, you can rewrite this as that. If you're given this, you can rewrite it like this.
Well, what is it? What does it do for you?
What does what do?
This.
Logarithm.
How does this apply to,
How does it apply to real life?
like if I was, is it like engineering? Like
Yes.
what engineering
Yes.
is?
There's a logarithmic scale that you use in engineering, and it's usually used with graphing. You don't use it a whole lot, but this is also manipulation of equations. And that's what you need to be able to do, whether you go into science or whether you go into engineering. If you want to get a formula to give you something, you've got to learn how to manipulate it. Manipulate it, you know, some of you women may, I'm sorry, bad teacher. Women know how to manipulate men. That it comes easy to them. That was a joke. All right. But that's what you need to learn how to manipulate. And women, men are not too hard to manipulate, are we? We're a jumper cable and y'all are a wiring harness for a 68 Camaro. Wires going this way, two wires together, wires going in different colors, one wire going here and ending, not going anywhere, and we're a jumper cable. So, two different, Mars and Venus. All right, and the last one. And we're going to do examples of these. The last one is, and you don't know this one, change base formula. Now, there's two types of logs that you can calculate mathematically. Right? There's two types of logs. There's log base 10, which is usually called LOG. In other words, if you see LOG of 22, then if there's nothing under the LOG, it's assumed to be log base what? 10. It's kind of like the square root symbol. If you see a radical and there's no 2 there, it's assumed to be the square root. Just like x. If you have x written, x plus 4x, that would be 5x. There's a 1 in front of that x, but you just don't see it. If you see this in your book, then it's assumed to be log base 10. The other log that you can calculate on your, and this is your key right here on your calculator, right there, LOG. The other log is log base what? Log base E. And what is that called? The natural log. Now, I am an LOG teacher. You will have some teachers that are LOG teachers, some teachers that are natural log teachers, some that are both. I can do both, but when I present everything, I do LOG. That's just me. You can use either one. You'll have to Google. I have gone through umpteen million mathematics courses at Clemson, at Tri-County Tech, and graduate and postgraduate, whatever. And I've yet to look up or find out why there is natural log and why there is log. So, you know, impress me. Find out why. Let me know. Because it's one of those things that's just assumed, and nobody has ever told me, or as in a teacher setting, teacher-student setting, nobody ever said, this is why we have natural log. I don't know. It's one of those things I want to look up, but I never do remember to look up. Change-based formula says, if I want to calculate log base n of m, and this is n is like a 2 or a 5 or a 6, because if it's a 2, 5, or 6, it's not one of what? Not one of these. So you can't calculate it on your calculator. So I've got to change it. And it's log base 10 or log base E, whichever one of these you want to use, of m over log base 10 or log base E of n. And now you can calculate this in your calculator, because this is either a 10 or an E, which if it was 10, if you want it to be a 10, then it's LOG. If you want it to be an e, then it's natural log. You will get the same answer. Okay? All right, now let's do some examples because we've basically covered probably 2 sections. So, let's go to the first. Somebody's got a book, and you tell me what page you see the product rule. I can jump right to it if you've got a book. Anybody got a book? See where the product rule is? What page? Okay, I'll just find it. Y'all, it's not going to help me. So. There's log base e is equal to natural log. It might tell you right here. I don't know if it tells you or not. Somebody read it. That's on page 342. Properties of logarithms. There they are right there. And you need to make these notes right here. These are numerical rules. Write those down. There are 1, 2, and 3. Write those down, and we'll do an example here on the next page. All right, let's do, well, we can do several of them, but let's just do C. Log base 5 of the square root, I can't even read that, I gotta blow it up. Log base 5 of the square root of 8. Log base 5, square root of 8. Now, why can't I use the definition of a logarithm here? It ain't got no what? It ain't got no equal sign. The definition of logarithm, both sides of the definition of logarithm have what? An equal sign. They're equations. This is a term. This is not. This is an expression. It doesn't have an equal sign. So you got to learn to use one of the properties. Did anybody look up natural log? And why it's natural log? What did it say?
I don't understand it.
What does it say? I told you first. They don't tell you. No, they don't tell you origin. The origin, I'd like to know what the origin is. In other words, why did we come up with log base C? Why? Where did it come from? That's something I've never known, never been told. All right, what can we do here? All right, now I'm giving you a rule of calculus here. You ready? One of the number 1 rules in Hubert's calculus class is radicals in calculus don't mix. That's one of my number 1 rules in calculus. And then I go on to tell my calculus students, whenever you see a radical in calculus, what do? Erase it. No, you don't erase it. Can't do that. I used to do that on my math test. When I didn't know something, I would erase it on my work, and I just do it, and I say, I did this. Well, that's not the problem. You got to have this. But anyway, you don't erase it. You what? Starts with R. You rewrite it as a fractional or rational exponent. So the first thing you do on this one is you rewrite with this radical, because that radical is doing you no good at all. So log base 5 of 8 to the what? 1 over what? 2. 1/2 power. Square root is written as the 1/2 power. That's why you see me when I use a calculator and I take the square root of something. I take, like if I took the square root of 8, then I'd say 8x to the y, 0.5. It's a whole lot easier than using the radical, especially when your calculator does not have a radical symbol on it. Which calculator does not have a radical symbol on it? The TI-89. Nope. Now you can look it up and you can use it, but why doesn't the TI-89 have a radical symbol on it?
Because if you use that, you're really smart. You don't need it.
No, you're not Rain Man. Because the TI-89 is a calculus-based calculator. And it's assumed that if you are in calculus and you're using a TI-89, that you know radicals and calculus don't mix. Anytime you see a radical in calculus, you're going to have to rewrite it, period. So that's what you do. Now, what rule can we use now? We're not trying to find what it's equal to, because there's no equal sign. We're just trying to rewrite it. What can we do now? What rule? I'll tell you this, it's not the change-based formula. Exactly. That's the only thing you can do. Because there's no what here? There's no multiplication, there's no addition, there's no anything here. So you bring this out front, and that's 1/2 log base 5 of 8. Now, they're not asking you this because they bring the change-based formula in later. What could you do now with the change-based formula? I put them all together. What would it look like with the change-based formula? And I'm going to put this in brackets just so you know where the 1/2 goes with the change-based formula. 1/2 times what? Over or 1/2 natural log of 8 over natural log of 5. And that's it. That's the answer. Now you calculate this in your calculator. Somebody go ahead, and so you'll know where the log is. Now, a natural log teacher would not do LOG here. Natural log teacher would have wrote, oh, there's the Jim again. I'm not waiting for him. Boy. The natural log teacher would say, okay, then that would be 1/2 natural log of 8 over natural log of 5. And that would be the difference. And you get the same answer. So what's the natural log of, what's the LOG of 8? That's not rhetorical, I'm asking y'all. Okay, y'all.
I don't understand you got the one figure.
What?
How you got 1/2 and then log 8 over log
Look at the
5.
power rule.
Yeah.
What do you do if you have an exponent with a logarithm? What do you do?
I got log 5 8 to the 1/2, but like the next step.
Yeah. Look at the power rule. All right. What does it say you do with that exponent?
You bring it up front.
There.
Right. I'm on the bottom step.
This step?
Yeah.
Oh, change-based formula.
Yeah.
Okay. The change-based formula says if you have log, let me go over here. Log base n of a number x over log. Wait a minute. I'm sorry. There you go. Log base n of x, and this base is not a 10 or an e. If n is not equal to 10 or e. In other words, if it's 2, if it's 5, if it's 1/2, if it's 3, then you have to use the change-based formula. And that would be log of x over log of n. So what's my base here? Mr. Craig? Yeah, Craig. So I thought you were Cleveland and Craig, y'all sit beside each other. Log, what's my base?
Log 5.
Okay, can you calculate that in the calculator?
Maybe. Probably.
No, I just told you on the previous. You're not listening, Mr. Craig. You're a failure.
Not.
What's log base 10 equal to on your calculator?
Log.
LOG. Look on your calculator. Where's your calculator? You don't have your calculator. That's a good thing.
So what if it says log base 10 as a button, and I just hit 8
There is
log?
no log base 10. It's just LOG. Oh, they put it on there for you?
I did.
Okay, that's LOG.
So I hit 8 and then the log, or do I hit log and then 8?
Well, it depends. You try it on your calculator. You'll have to. On the TI.
So is it a decimal?
Upside down. I want you in the negative. There's your 2. Now, what does that say? And that says that's the only 2 that you can calculate. All right. What is the natural log? Log base what? So, if you're doing, sorry, thank you. If you're doing a problem, and let's say you just log base 2 of 4. All right, that's a problem on the test. You know you can't calculate that because this is a what? 2. You have to have a 10 or a what? E. If it's not 10 or E, you can't calculate it. So the way to change this into a calculatable problem is to take log base 10 of 2 over log base 10 of 4, or log base E, which is what? Natural log of 2 over natural log of 4. So these two are calculatable, or calculable, or whatever the word is. You can calculate these two on your calculator, but you can't calculate this one. Okay? Now, what if I gave you this? LOG of 4.
That's log base 10 of 4.
Why?
Because it's not...
Because if there's nothing here, it's assumed to be what? A 10. And you need to remember that. Because you might...
So all you do is write it log base 10 of 4.
Well, you don't have to. You just put log of 4 in your calculator. Okay, on the TIs, don't you type log and it gives you a parenthesis, and then you type in 4, close parenthesis, and then enter. Huh? Yeah. But what does yours do?
Sir?
How do you do? You probably have to hit 8, then log. Or what's
Yes,
it?
sir.
Yeah. Most of your non-TIs, you put 8, and then you hit log. Or natural log. But you'll get the same answer.
Is that going to like make any difference in terms of a coefficient problem, where there's a coefficient up front? No.
No, you just multiply it, just like we did here. Okay, I was going to ask y'all, we were right here. All right, somebody take the log of 8. What do you get? Just give me 4 decimals.
0.9030.
9030. All right, everybody with me?
Yep.
All right, now give me the log of 5.
0.6989.
All right, do this math inside the bracket, 0.6989. Do that math. Somebody give me the decimal. 4 digits, 4 decimal places. 9030 divided by 6989.
1.2920.
And then multiply that by 1/2. Dang old. 64.64 something.
0.6460.
And that's your final answer. Now, the book did not ask for your final answer because the book is not giving you the change-based formula yet. I have. So, if you want to do some extra practice, whenever you do one of these, go ahead and you get something like this. You get something like this, go ahead and do the change-based formula. And therefore, when you get to the change-based formula section, you'll already know how to do it. So the only thing that you had to do on this one is what? Oh, shoot. The only thing you had to do on this one is this. That's all that you had to do. Yes, sir.
Does log base 5 go on top, or does log base 8?
Oh, did I do it? Oh, shoot. I'm sorry. Look at log base 5. I'm sorry. I did it fast afterwards. I suck. All right. I'm a terrible teacher. Y'all need to redo y'all's evaluation. Is that the same evaluation that asked, would you take another course from this instructor? Is that the same evaluation?
Yes.
They haven't changed it in years. All right, we're going to have to redo it. Just invert your fraction. What's the top one?
Log base 5 over log base.
Yeah, log of 5 over log of 8. And
So is the formula that you gave us incorrect? Because the formula that you gave us, if you follow it, you would do it like you did.
the base is supposed to be on the top. That's what it's supposed to be. At least we'll check it. Let's check it right quick because I might have had a brain bubble when I wrote it on the board. Where's my book?
Yeah, I see what you're saying.
You cancel down to
I did what?
it's the third one. It's the second one right here.
The second one?
Log base
Oh. Can't I just hit this? There we go. Somebody look and tell me what page the change base formula is on. It should be a couple of pages after.
60,
I'm sorry, what?
maybe 360?
360?
363? Yes.
Okay. I think the base is supposed to be on top. If the textbook will ever come up. Any day now. $363. It's not on. It's not there. Nope.
Can you search it?
I'm just going. It's in this section or somewhere. There it is. 365. It should be. Let me blow it up. Hold on. Okay, it's that. Okay, I had it right the first time. It's the number over the base. Number over the base. So let me look at the. Hold on. Just stop. Let me make sure I wrote it down right. Yeah, there it is. That's right. This is right. Log of m over log of n. The base is on the base. Just remember the base is on the base. And that means the first time we did this, it was correct. Okay, so my bad. Or somebody's bad. I don't know whose bad it was. Maybe mine. So 1/2. That's the log of 8 over the log of 5. And y'all tell me again what the final answer was.
Like
0.60.
460.
I'm sorry, what?
0.6460.
6460. When you do the math, 3 dots vertically means, okay, y'all do this work. You should get that answer. 3 dots like that means do the work, get the answer. What does these 3 dots mean?
Mean the end. No.
Therefore.
Therefore.
Or if you're a movie buff, dang old Predator, dang old weapon. Dang old hand. I love the Predator. I think they ought to have. Now I had the original idea of Freddy versus Jason. I said a long time ago, before Freddy versus Jason, I said they need to have a movie with Freddy being in Jason's dreams. Now don't you know that would be screwed up? Now if they didn't do that, they did it in somebody else's dream. But wouldn't it be weird to be in Jason's dreams? Can you imagine what that would be like? You'd have to get Stephen King to actually write that. It'd be weird being Jason Voorhees' dream. And then Freddy being in that dream. But I think they ought to have Freddy, Jason, Michael Myers, and the Predator. They need to have a movie like that. I think the Predator would win, but he'd have to shoot them like 5 or 6 times. Or take that spear and cut their heads off. Okay, so that's my idea. So when it comes out 2 or 3 years from now, y'all going to be witnesses when I sue them. Okay? I'm just kidding. All right, so, okay, it's time to go. All right, what I want y'all to do is work on What section is this on 365? What?
5.3.
5.3. Y'all need to work on 5.1. Right now, y'all are responsible for 5.1 through 5.3 homework. And whatever we cover, what day is it? Monday? That's the, I got to get the roll, y'all. I'm sorry. Don't run off yet. I don't know where my, shoot. I wish they would quit logging us out of everything. I think I know who's here, but tctc.edu. Chances are, when y'all come back next week, we will be going over solving equations. So you have got to do the homework to get used to these properties. Okay? And faculty and attendance and shut off the do